This video is going to be a quick overview on how to complete the square and use that in solving quadratics. Let's get started. The assumption is going to be that you have already learned how to factor perfect square trinomials, such as this one on the left. And if you haven't, go back and look at the video for solving perfect square trinomials, or sorry, factoring perfect square trinomials. This trinomial on the left can be factored by turning it into x plus 5 squared. And the reason is that the square root of x squared is x, and the square root of 25 is 5. And since the middle term is a positive number, that's going to be a plus right here. And that's all going to be equal to 36. So I've just simplified the trinomial. Now what I can do is go ahead and take the square root of both sides. And when I do that, the square root of something squared, of course, is that number itself, x plus 5. And that's going to equal plus or minus 6, the square root of 36. Now what I can do is I can set this up as two different equations. One is going to be a plus 6 and one will be a minus 6. And I can solve to find out what the two possible answers are. X plus 5 equals 6 or x plus 5 equals negative 6. And then what I'm going to do is add 5 to both sides, or sorry, subtract 5 from both sides, and I'll get x equals 1. And on this side, if I subtract 5, I'll go ahead and write it out. That's what I'm doing. If I subtract 5 from both sides, I get x equals negative 11. So there I've actually solved a perfect square trinomial. And in the next example, we're going to talk about how to actually complete the square. These are two problems that are perfect square. Well, we want them to become perfect square trinomials, and they're not yet. And so what we're going to have to do is find the third term in both cases that will turn these into perfect square trinomials. So just kind of quick review. A perfect square trinomial is one, like here in the pink, that has 3 terms, and the first and third terms are squares, and the middle term basically is has a relationship with this third term. And the relationship is that you can take the coefficient of the middle term and divide it in 2. That's why we have this b over 2 and square it. And that's going to give you the constant of the trinomial. Then when you factor it, you take the square root of this first term, which is going to be x, and the square root of the third term, which will be just b over 2 squared. Let's see how this would work. In number 1, the coefficient of the middle term is negative 8. So I can simply take negative 8, and I'm going to cut it in half, and I'll put parentheses around it. I'm going to square that whole thing. Well, negative 8 divided by 2, or cut in half, is negative 4. And negative 4 squared is 16. So I've completed that to make it a perfect square trinomial. In the green example, I can take the coefficient of my middle term, and the coefficient 7, and I can put it divided by 2. I'm going to square that whole thing. And I'm going to go ahead and just leave it as a fraction. And the square of 7 over 2 squared is 49 over 4. And now I've completed that and made it a perfect square trinomial. Let's put this to work. If my video runs out, I'm going to continue on the video identified as number 2. Here we're going to go ahead and use that skill to complete this and perfect square trinomial and make it a perfect square trinomial. And what I have here is a constant that doesn't quite work. Plus 5 does not make this a perfect square trinomial. So what I'm going to go ahead and do is move that to the other side. What I'm really doing is taking 5 from both sides. And I'll now end up with x squared minus 12x equals negative 5. Oops, be negative 5. And what I'm going to do is find out what I need to put here as a constant to turn this into a perfect square trinomial. So I take the negative 12, that's the coefficient of my second term, divide it by 2, and square it. Well, negative 12 squared, negative 12 divided by 2 is negative 6. Negative 6 squared is 36. So I'm going to put 36 here, right here. I'm adding 36 to the left side, and I'm going to go ahead and add it over here onto the left, to the right. Because whatever I do to the left, I have to do to the right. Now I'm going to go ahead and erase this work right here really quick. And I can turn the left side into a factored perfect square trinomial.